Here's another example. You decide to open, it's on a smaller scale, you decided to open a Christmas Club account at a bank that pays 6% annual interest compounded monthly. And I just can't go any further because the 6% is calling my name. It's the interest rate, so that's going to be the R equals. And it's annual interest compounded monthly. So this annual interest thing, sometimes you'll see that, but since it's saying compounded monthly, we're going to ignore the annual interest part and say, okay, that means my N is 12 because it's monthly compounding, and this annual interest is just another way of saying APR. Okay, you deposit $100, so that's your payment, on the 1st of January and on the 1st of each succeeding month through December. So it looks like a full year, January all the way through December. So my T equals 1. I have 1 year that I'm depositing. How much will you have in your account on the 1st of December? So that would be after you make your last deposit. So number 1, we're going to write down that formula first, and it's FV equals PMT times 1 plus R over N to the NT power minus 1 over R over N. And then I'll start filling things in. So future values, what I'm trying to find, $100 is the payment amount from up above. We wrote that. And then we have 1 plus my R is 0.06 from 6% over 12 for monthly. And that'll be 2 to the 12 times 1 for 1 year for the T equals 1. Subtract off the 1, and then it's going to be over 0.06 over 12 again. Now this one, since we're not doing annually, we're going to have this R over N that we have to calculate 2 times. And in fact, if we calculate this entire numerator and then we want to divide by something, we might want to just store this in our calculator so that we can use it both times. So I'm going to show you how to do that using store and recall on your calculator. It's pretty simple once you learn the procedure. So I'm thinking you'll like it, especially for the annuity formulas and the installment loan formulas, which are coming. So first thing I'll do is 0.06 divided by 12. And I get 0.005. Now I know I could just write that down, and I will, 0.005 instead of that whole thing, and down here 0.005. But I do want to show you how to use store and recall, because occasionally you'll have like 0.083333 or something like that, and you want to be able to store all those decimal points. So we'll just say for this calculator, we'll store it in A. And so what I'm going to do is the store button, which is right there, and click the store. And then it shows me choices. Where do you want to put it? A, B, C, D, E. And you can just move between those storage spots by pushing the arrow key. So I can go from one to the other. And it's showing me that I have a couple of things stored in there. It doesn't matter. I'll come back to A, and I can just push enter, and it'll overwrite whatever was in the storage bin. It's just like a place in memory where you can store something. So in A, I have stored my answer, and it has a value of 0.005. So now I know it's taken place, and when I do a recall, I'll get that 0.005. So back to our formula, we have this 0.005. We want to add 1 to it. So it's sitting on my display right now, the 0.005. So all I have to do is say +1, and it gives me 1.005. That gives me this whole part in the parentheses here. I have to raise it to this 12 times 1, which I already know is 12. So I can just do 2 to the 12th. And then subtract 1, because that's the next thing that my formula says to do. And I have 0.06, 167, on and on. So I'm going to take a minute here and just write what I have. It's really helpful if you do that occasionally. I don't require you to write out your work for every single step, but if you're having trouble finding your error, write out your steps so that I can look through and see where you made your mistake. So my numerator is 0.06167 and it goes on, and that's going to be over what I stored in A. So I will just divide it by, it's sitting on my calculator, divided by, now I want to pull back what I have in A. If you look here, this right above the store, it says recall RCL. That's what I want to do, so I have to do second store to get the recall. And then again, it shows me all my variables where I might have stored things, and there's a couple I didn't use. So there's A, that's the one we put, and so we'll put equals. Now it's showing that it's going to take my answer divided by that 0.005 that I stored. And so I'll say, yes, that's what I want to do. Push enter. And now I have equals 100 times 12.335. And so now last thing times 100. So I have $1,233.55, but I'm looking at the next digit and it's a 6, so I'm going to bump that 5 up to the next one higher, which will also be a 6. So we will have $1,233.56 in the account December 1st. Not bad. Number 2, how much did you actually deposit? So that's like what we were asking before, where I was saying, how much money would you have if you just stuck it in a sock in the corner of your closet? So how much did you actually put in? Remember, you were putting in, we can just say it's the payment. We'll make a quick little formula here, times the number of deposits that you made, which will be however many times you're depositing each year times how many years, right? So it's your NT. If we fill that in, mostly people can think about this and they can come up with what to do to find this, but sometimes people get stuck. So I'll just give you a little formula. You do need to memorize how to do this. I won't give it to you on a formula sheet, but this will get you started. So our payment, remember, was $100, and our N, we were making monthly deposits for 1 year. So we have 100 times 12 times 1, and that's going to give us $1,200. So actually deposited. And then number 3, how much interest did the bank pay you? Well, if we know how much money we have at the end of the investment period, and we know how much money we actually contributed, the rest of it is money that the bank is giving us. So we will take the future value minus the contributions, and then we will get our amount of interest that we earned. And so the future value was $1,233.56, and we subtract off the $1,200 that we actually deposited, and that leaves us, I can see it, $33.56 interest. And that's pretty good actually for a small annuity and for a short period of time. So $33.56 interest that you earned on that account.